For the last question on this paper, we're told that we have a function f of x, which is an exponential function in the format a to the power x. We were also told that a is greater than 0. If a is in the exponential functions, if a is greater than 0, it means that it occupies the first and the second quadrant. If a is less than 0, meaning it's negative, it occupies these two quadrants. We're also then told that the graph passes through a point where x is 3 and y is 27/8. The first question asks us to find the value of a. So f of x is equal to a to the power x. We have our y, 27/8, is equal to a to the power 3. We don't want to the power 3. Find the cube root. Find the cube root. Our a is 3/2. Now, the second question is asking us to find the inverse of the f of x function. Our f of x function is equal to 3/2 to the power x. The first thing you need to consider when we're dealing with inverse operations is switching your x and a y. So we're going to replace our x with the y, our y with the x, then 3/2, and then y. Now from this point, we were trying to solve for y, make y the subject of the formula. And because the y is occupying the exponential region, we're going to use our logs. Y is equal to log, our base is 3/2, and then x. This is our inverse function. Now, we need to determine the values of x for which the inverse is equal to -1. The inverse is equal to, remember, x to the power a is equal to b, but a is equal to log b a. In our case, negative, if we go back, if we return from this equation to this equation, our -1 is going to be an exponent, our base 3/2, so 3/2, and then -1, our exponent, x is going to be the inverse of 3/2 is going to be 2/3. So values of x for which the inverse of x is equal to -1, 2/3. If you insert the 2/3 in your inverse function, you have to get -1. The fourth question is asking if h of x, the new function, is equal to f of x minus 5, what is the domain of h of x? Now, remember, this is our f of x, the original function, our f of x. H of x is just the transformed version of f of x. But what kind of transformation are we looking at? Because the transformation occurs within the brackets, this means that we're moving the graph horizontally, either left or right, but horizontally. If we had made a transformation, say, where f of x minus 2, if we had made a transformation outside of the bracket, then that would mean we're moving our function vertically up or down. But now, since it's within the bracket, we're moving sideways. So for this instance, it's -5, meaning that we're moving 5 units to the right. So our new function will probably look like this. Now, the domain of this new function, remember the domain simply refers to the x values that the function can cover. And we know that our exponential functions move to infinite numbers. Therefore, our domain is going to be x is an element of real numbers. It covers each and every value. So x is an element of real numbers. Now, for the last question on this paper, we're told that we need to draw a function, an exponential function, where a is less than 0, b is greater than 1, q is less than 0. We need to first understand how each variable impacts the entire function so that we're able to draw it. The first thing we look at is a. A simply tells us, I reiterate again, A simply tells us which two quadrants is our graph going to occupy. If A is greater than 0, then that means our function is going to occupy the first and the second quadrant. But if A is less than 0, it means that it's going to occupy these two. So we already know from this that our function is going to be down here. Now, B is greater than 1. B is greater than 1. For instance, when we think about these two, when B is greater than 1, that means that our function is going in this direction. B is greater than 1. But if B is less than 1, but greater than 0, meaning fraction, then that means that our function is going to look like this. This is how it would look if A is greater than 0. If A is positive and B is greater than 1, then our function would go like this. If A is greater than 0 and B is less than 1 but greater than 0, it would be moving in this direction. And then when we come to the bottom where A is less than 0 in negative, we also have the same flow. When B is greater than 1, we just reflect our function. B is greater than 1. But when B is less than 1, but greater than 0, meaning the function, then it's going to be a reflection of that. So when B is greater than 1, with A being greater than 0, the function goes up. But when A becomes negative, it reflects it down here. The same goes for these two. So we already know that our A is negative, meaning it occupies these two positions. We already know that our B is greater than 1, meaning that it has to take this shape, from this to there. And then Q is the y coordinate of our asymptote. So we are told that our y asymptote is going to be negative. Okay. Any value, we don't know, just take any random value, our Q, our y asymptote is negative. Our function is going to be on these two functions moving in that form. So this is our function going from